So in the previous lesson we were talking about the cell dogma and DNA, RNA, proteins, but we didn't actually talk about the basic building blocks of life. And this is one of the most important things I'm going to do in these biology lessons, where I promised you in the first introductory video that I'm going to touch the subjects from the smallest fundamental units of everything, the building blocks, all the way to the actual structures, the organ, the tissues, the physiology, which is extremely important to understand. But in order to do it, we have to first of all have a very solid foundation of the basic knowledge you need to know. So in the previous videos we were talking about the central dogma. The central dogma only showed you what each cells can have in order and can do in order to make proteins inside the cells. But what are proteins and what is DNA or what is RNA? So in this lesson we are going to discuss the smallest unit of everything you see around you, and the smallest unit of DNA, the RNA, the proteins. And then we are going to slowly build our knowledge on top of it. We are going to go from atoms to molecules to cells to tissue to organs to physiology, etc. So what is an atom? If you take this book, for example, which is the fifth time I'm giving it as an example, and you're going to take a knife and you're going to cut it into many small sections, and you're going to try to reach the smallest part as you can go. So this book is made out of billions and billions and trillions of a unit called an atom. An atom is used to be thought to be the smallest unit of anything you see around you. But actually, atom is not the smallest unit. The atom is made out of three things. Obviously, it's made out of more, but we need to know about three things that is made out of. So what is an atom? The very incorrect, old-fashioned way to visually represent an atom is as the following. So you have the core, and you have the orbitals around the atom, around the core of electrons. And it used to be thought that this is how an atom looks like. You have the core, which is made out of two particles we are going to discuss in a few minutes, and you have electrons that are being orbital, such as the sun and the earth. So the earth goes around the sun in a circular motion, every way, in the same speed, and this is what is used to be thought about electrons as well. But recently we understood that this model is incorrect completely. And what is more correct when it comes to quantum physics and chemistry is that orbitals are actually an area that is electron is statistically likely to be in this area. So imagine you have a circle around an orbital around the atom, and you have a 3D structure, like it's a 3D orbital. You can see it's like a ball around the core of the atom. The electrons are, let's say 95, are very likely to be inside this orbital around the core of the atom. We don't know exactly where the electron is at a specific point of time. We do know, however, that the electron is most likely to be inside this orbital. And in the future you will see that there are many kinds of orbitals, many shapes of orbitals, many orientations of orbitals. But when it comes to the basic orbital of the basic atom, the basic structure, orbital is just where electron is most likely to be at a specific point of time. It can be everywhere, like anywhere you see inside the circle and even outside the circle. It's only a matter of statistics when it comes to quantum physics and chemistry. So what is the core of the atom made out of? So what we know that the core of the atom is made out of two particles that are very important. One is the protons. The protons are positively charged particles, and the number of protons will represent the element we are talking about. The number of protons inside the core of any atom will show us and tell us which element the atom is. For example, if we have 6 protons, the following element, the following atom will be a carbon atom. If we have 2 protons, the following element, the following atom will be helium, etc., etc. The second particle we have inside the atom, the core of the atom, is something called neutron. Neutron is neutral, as the name suggests. It doesn't have any electrical charge. However, it weighs a similar weight very close to the proton. So, for example, if the weight of the proton will be 1, we can say that the weight of the neutrons will also be 1. And when it comes to carbon, for example, you can have different amount, and many other elements as well, you can have different amount of neutrons inside the core of the atom, and it will still be the same atom, the same element. So, for example, carbon can have 6 neutrons, 7 neutrons, 8 neutrons. It will affect the overall atomic mass of the atom, but it won't change the atom itself. So let's say this carbon atom will have also 6 neutrons. And this is our atomic core. This is the atom's core. And as you can see, the neutrons are 0. They don't have any electrical charge. And the protons are +1. We represent them usually as +1, which represents the atomic charge. Now, an interesting fact that the electrons that are around the atom all over the place, around the core of the atom, are -1. They represent, each electron represents a -1 charge. However, they weight close to 2000 times less than protons or neutrons. So it's a big difference between protons and neutrons, and this is why it doesn't really matter what is the amount of electrons you have around the core. In order to calculate the atomic mass, we only take into consideration the amount of protons and the amount of neutrons. Now that we understand the general concepts when it comes to atoms and the smallest unit of elements and everything you see around you, I want to discuss and to talk about something pretty interesting. So carbon is known to be the backbone of life. And the amount we should know by now from the books and the things you should study, or if you don't, the atom, the amount of electrons, protons and neutrons affect the likelihood and the amount of bonds and the strength of the bonds any atom can create with different elements or the same elements. So carbon is very unique because carbon is small enough in order to create 4 bonds, which is a lot, with other elements that are either smaller than carbon or bigger than carbon, and it also has enough electrons to support exactly 4 connections to the carbon. And the most important thing is that carbon have covalent bond. It creates covalent bond, which we are going to discuss very soon, with 4 elements at the exact same length, size, and strength. So what do I mean by that? Carbon can create 4 bonds, which is usually you see elements that can create a single one, double one, maybe 3 bonds, but carbon can actually create 4 bonds with much smaller and bigger elements. And because carbon is so unique, it's in the exact it's in the sweet spot of size, covalent bond strength, which we are going to discuss in the future, amount of electrons, the orbitals, in order to create very solid, reliable 4 bonds with other elements. Having something that can create so many solid bonds with other elements is the element that is more likely to be a backbone in many different molecules. So we can see it in nature, where carbon is everywhere in our body, the trees, anywhere around us, and carbon represents and acts as the backbone of many molecules. So we are going to talk about amino acids and fatty acids and sugars and carbohydrates, and you're going to see that carbon is in the middle of each molecule, in the middle of each formula. It holds all of the molecules together because, again, carbon can create so many solid bonds, and it's in the right size to create so many solid bonds, while it has the orbitals, the right orbitals to create the following covalent bonds with different elements. So this is something that we are going to see very soon. Now, I mentioned the carbon as the backbone of life because in the next lesson we are going to talk about the micromolecules that build everything inside the human and the animal body. So when it comes to cell, for example, the cell is made out of a plasma membrane, a nucleus that we mentioned in the previous video, proteins, and these structures, the proteins, the plasma membrane, are made out of amino acids and fatty acids, which are the smaller parts of the cell, of these specific organelles and parts of the cell. And if you take the molecular structures of the fatty acids and the sugars, you will see carbon as the main molecule and the main backbone inside. So this is why it's very important to understand, first of all, that the atom is the basic unit of everything you see around you. A step after it is to understand that carbon is the backbone of life, which is basically means that carbon can create the specific bonds with different elements in order to create the molecules that create the cells, that create the tissues, the organs, etc. And in the future, where we understand the carbon and the atoms, we are going to start seeing and building molecules and understand how they function. So in the next video, I'm going to discuss about proteins and amino acids. So I'm going to do a short introduction to the next video I'm going to take, which is amino acid is a specific molecule that contains carbon, oxygen, hydrogen molecules, and nitrogen. And you can see the structure with the carbon in the middle as the backbone, and many different molecules are connected to this carbon atom in the middle. And you will see that the difference between amino acids is that you have the backbone that stays all the time and only a specific group changes. So it's something that's very important to understand from now, is that carbon has a lot of unique properties that we are going to cover in future lessons. So I hope this video gave you a bit more understanding about atom and about carbon in the future. And we are going to talk about carbon a lot in the future as the basic molecule, the basic atom of everything we are going to discuss when it comes to molecular biology. So I'm going to keep talking about it in the future lessons, and I'm going to explain more about amino acids in the next lesson. I hope this video made sense, and I will see you next time.